Ladies and gentlemen, I'd like to introduce Mr. Nitin Naik. Mr. Nitin is the founder and managing partner of DuPont, based out of Goa. With over 30 years of experience in the HVAC field, he has spent a third of his career managing HVAC projects for MNCs in the pharma and FMCG sectors. Leveraging his expertise, he embarked on the entrepreneurial journey, representing industry leaders in the HVAC and IAQ space, serving clients in the pharma and building construction industry across India. He actively advocates for the HVACI professional and represent his peer through various regional leadership roles in ASHRAE, ISHRAE, and IAQA. Today, Mr. Nitin will talk on indoor pollutants and IAQ monitoring. So, without any further delay, let's welcome Mr. Nitin.
From India, and if there is anyone from outside India, a good evening or a good morning to you all. For today is IAQ solutions for a greener future. It's very interesting to note here that IAQ always has to piggy ride on something which is green, and which also tells us that in our industry, we are all the time giving preference to something which is either green or energy efficiency. So what we are doing is all of us are prioritizing operating costs over the health and well-beings of the building occupants. I don't know where that takes us, because the future may be green, but I am not sure whether we will be there to see the green future. So specifically, I will be talking on indoor air pollutants and IAQ monitoring. So when we talk about indoor air pollutants, we generally in commercial buildings or residential buildings, what we monitor is particulate matter. We monitor TVOCs, we monitor CO2, we monitor temperature and humidity. These are the basic minimum pollutants that we need to monitor to ensure that we have good indoor air quality. All of you are familiar with temperature and humidity, which actually talks about thermal comfort. I am going to spend a little more time talking on particulate matter and carbon dioxide in indoor spaces, but I will run through the other pollutants. So ASHRAE defines thermal comfort as that condition of the mind that expresses satisfaction with the thermal environment and is assessed by subjective evaluation. If you see the picture on the screen right now, someone is feeling cold, someone is saying it's okay, someone is hot. Most of our public spaces have these cold or hot spots, but more often than not, if you see our public spaces, they are absolutely chilled, if I can use that word. Very often when I attend seminars or I attend a banquet function in hotels, or even I travel very frequently on work and I stay in hotel rooms. And most of these places, if not all, are extremely cold. I don't know what that means for us, but the whole problem lies in the fact that we live in a country where when air conditioning in our spaces is chilled or very cold, we consider it to be a very good air conditioning system. And that's the sad part of it. I'm going to show you what happens in a real case scenario. If you look at this slide over here, the top trend which you see on the slide is temperature and humidity at the bottom. Humidity is well maintained. This is a guest room in a hotel, and this is not an exception. This happens most of the time. When I enter the room, I set the thermostat at say about 25 degrees centigrade. This time I had set it at 26 degrees centigrade. Throughout the night, if you notice, my room was maintained below 19 degrees centigrade. Yes, below 19 degrees centigrade, it's extremely uncomfortable. There is no comfort at all. This is what is happening in most of our buildings. We want to save energy. We don't monitor, we don't measure, and hence we are always guessing. If you see, the difference between the actual temperature and the set temperature is about 5 to 6 degrees centigrade. If you just go by BEE norms, it means that the building is wasting about 15 to 20% of energy in terms of operating costs. Let us look at TVOCs. We all know volatile organic chemicals, and these actually are generated by the building material that we use or material that we use after a building is finished. The sources is mentioned on my screen. The T in TVOC actually stands for total volatile organic chemicals. It is a representative figure. So pesticides, adhesives, which we use, traffic emissions, which infiltrate our buildings, cosmetics, which we use, the furniture we use, the laminates, everything, there is off-gassing. Our paints on our walls also are off-gassing. So it is up to us to limit the use of material which has higher VOC content to go for eco-friendly material to reduce VOCs. But I would, all VOCs are not bad. What we need to do is every monitor or every sensor that you use will have a different measurement for VOCs. That is because there is no uniform standard in the world today, and every manufacturer samples a different set of VOCs. That is why it is called TVOC and it's a representative figure. So I would have a word of caution here and say, if you are monitoring TVOCs, be more interested in the trend that the TVOC shows instead of just the absolute value that it is showing you. Particulate matter and CO2, I call them the real elephant in the room. If you see the screen here right now, what you see on your extreme right, a rope-like figure or a rope-like object, is actually the human hair. And that is denoting the diameter of the human hair vis-a-vis a 2.5 micrometer dust particle. Why 2.5? The most frequently measured particulate matter in our indoor spaces is PM 2.5 and PM 10. PM 10 is not as what you say dangerous to us as PM 2.5. And why is that? It is because PM 10 more often than not gets arrested in our own body's defense mechanism. It gets arrested, say, in our nose, in our mucus. But PM 2.5 escapes all this. And there is enough evidence today to see that PM 2.5 material enters our lungs, it penetrates our cardiovascular system. There is emerging evidence today that it also enters our brain and is responsible for a lot of the mental health ailments that we have. It also penetrates our bloodstreams and our arteries. So there is PM 2.5 is a very, very serious pollutant that we should consider, and somehow it is very underrated. In our country, we don't give enough importance to PM 2.5 pollutant. Lastly, let's look at carbon dioxide. We all have been in crowded spaces. We, in fact, throughout our day, we spend a lot of time in different spaces, and many of these are crowded. Being in crowded spaces is one thing, but whether the space is ventilated enough or no, we do not know. The problem with indoor air quality is that air is invisible, and very often bad air or poor indoor air quality is even odorless. So even by just sniffing the air around you or in your normal breathing process, it's difficult for you to find out whether the indoor air quality is good or bad. All of us spend 90% of our time indoors. That means if we live for 50 years, 45 years are spent indoors. But we do not give indoor air quality as much importance as we give other aspects in the building industry, including, say, outdoor air quality. Media gives attention to outdoor air quality. We never read about indoor air quality anywhere. And that is why even a webinar like this has to use the word green to attract attendance. And that's the fact. So what happens with high levels of carbon dioxide in a space? You have all these symptoms of drowsiness, dizziness, confusion, headache. It's fine. Maybe you can weather these, but all these sustained elevated levels lead to a syndrome called as a sick building syndrome. Somewhere it gets to your system, it gets to your health and well-being. There is research which tells us that when you are working at your workspace, if the CO2 levels are high, for every 400 ppm rise in CO2 levels, there is a cognitive function score which decreases by 21%. And that is why sometimes we find that we are not productive or effective at work. Our bedrooms, where we spend a third of our lifetime, we use air conditioners, and in that process, to save electricity costs, we make our windows and doors tightly sealed. And then when we wake up in the morning, we are fatigued, we are tired. It is because of sustained levels of CO2. But sustained levels of CO2 and its effects like shortness of breath or increased heart rate and blood pressure is known for us for a long time. But there's another concept, which is an interesting concept, which I'm going to introduce to you right now, is the concept of rebreathed CO2. And this table has been simplified by a person called David Elfstrom from Canada. You can follow him on LinkedIn and other social media handles. So what he says, in fact, is very simple to understand here. If you have high levels of CO2 in a particular space, it first of all means that there is poor ventilation, because the levels of CO2 is an excellent indicator whether your ventilation system is working or not. And CO2 levels will go up or down based on occupancy in the room. If you have more people and they go about doing their normal routine, CO2 levels will increase unless you dilute it with outside air. There is no other method to mitigate CO2. So if CO2 levels are 800 ppm in a room right now, it means that 1% of the air that you're inhaling has come out from someone else's lungs or someone's lungs. So if you are in a room where the CO2 levels actually go up to 5,000 ppm, it means that 12% of the air that each one is inhaling in that room has actually come out from someone else's lungs. Now, we never think about it like this, and that is why we are okay with high levels of CO2. But when you think about it, I don't think any one of us would want to breathe that air. But very often what happens is we do not know that this is the situation, and we can't stop breathing, because breathing is very essential for our survival. You can defer drinking a glass of water if the water is dirty to a later time. You can't stop breathing. You do not have that liberty when it comes to breathing. That is what makes IAQ even more important. So I will show you a real case here. I was in Mumbai a few months ago speaking to a group of architects. Their lovely office where there are about 100 people sitting, and they have a lovely meeting room. That meeting room apparently did not have ventilation, and 20 people in that room. And ironically, I was speaking to them on indoor air quality. Look at the trend on this picture right now. Within an hour, we started at around 10:30, I think. Within an hour, the CO2 level has entered the red zone over here. And by the time we finished our session around lunchtime, say around 3.5 hours, the CO2 had gone up to 4,500. If you remember the figures from my previous screen, that means at this particular point of time, 11% of the air that we are inhaling was from someone's lungs, which is not a very interesting to be seen. I'm going to show you that screen again. That means 1 in every 8 inhaling breaths that I am taking were from someone else's lungs, or maybe from my own lungs, which has come out. This is not a very interesting thing that we would all want. So 4 ways to improve indoor air quality: effective ventilation, good humidity, maintain humidity in the range of about 40 to 60%, cleanliness or housekeeping, and air purification. I'm going to quickly run what happens that we want to maintain good IAQ. The first step that we need to take is to measure. If you do not measure, you cannot manage. And when you don't measure, you are only guessing. So you need to start collecting and interpreting IAQ data. And how do you do that? You do it only by continuous monitoring. If you think that you can do that by doing occasional IAQ tests in a building, it will not give you the true picture. It will only tell you what is happening at that moment in the building. But indoor air quality is dynamic. Our buildings are dynamic. The outside ambient conditions keep changing. That is dynamic. That is why there has to be a continuous monitoring. So you need monitors, you need sensors which are placed which are placed in a building at strategic places, places that give you a true picture of what is happening in that space at any given time. And devices, sorry, should be in the breathing zone. Breathing zone is something which is defined as a wall mounted device to be wall mounted at a height between 3.5 feet to say about 6 to 6.5 feet. That will give you a proper reading to take correct action. So how do you go about this? The first thing that you will need to do is select a good IAQ monitor. And what is a good IAQ monitor? For our commercial buildings, you need a good quality commercial grade monitor. So if you are going in for a well certification, you need to ensure that that monitor is complying with the requirements of well certification. You're going for some other certification, you need to comply accordingly. So typically a good monitor is classified as something which is reset grade B certified in our industry. You need to know how that monitor collects data, how it stores data, and how it displays data. Do you want a monitor with a display or without a display? Does it adhere to building automation specifications of that building? Monitors can be connected over Wi-Fi and data can be displayed on common displays within the building. So you have to decide, each building will have to decide how you want to manage your data, how you want to have the option of seeing historical data, because you may be having a monitor for 6 years, but you would want to know what happened on a particular time 3 years ago. You should be able to go back and see that trend, analyze that trend. The display given to you should be user friendly, should be friendly to be analyzed. The company giving you the monitor should be also be able to give you a good dashboard and good analytics, because you need to understand what is happening in your building. Just looking at a few digits like temperature, RH, CO2, TVOC, and PM doesn't tell you anything. But understanding the trends, what happened in your building, actually tells you the real story and helps you take corrective action. And the most important feature in the monitor is calibration. Over a period of time, sensors tend to drift, and any sensor which has started drifting, it cannot be corrected by just adjusting the error. You need to replace sensors for calibration. So that is a very important factor that you need to keep in mind, that every monitor that you have or every device that you have should be calibration friendly. It should not be one that helps you just adjust the error which is being shown. And most importantly, in conclusion, I would like to say that we should all move to a mandate where all our public buildings are forced to display their indoor air quality prominently at some place in the building, because it is only when they are forced to display the indoor air quality we will see improvement in indoor air quality in our indoor spaces. Thank you.
Thank you, Mr. Nitin, for talking about indoor pollutants and IAQ monitoring.